My talk is on GraphQL, and it's titled "Why Should We Care?" But a more appropriate title would be "Why I Care and Why I'm Hoping to Introduce It at Honest," where I've been the director of engineering now for about 4 months, and we're leading a transition. We're starting to explore GraphQL as an alternative to Meteor, which our legacy stack is on, as well as Rest. Okay, so how many of you folks have worked with GraphQL before? Tinkering in production? Okay, a lot. So you guys have more GraphQL experience than I do. Okay, so I've been tinkering with it for the past month now, and this talk is to share sort of our motivations behind it. Right? And we're going to start with thinking about JavaScript or client-side code in general. What do? We provide awesome interactive user experiences that were formerly exclusively limited to desktop users. Right? Modern-day web apps and mobile apps are extremely interactive. They're being asked to do a lot more than I think the people who invented JavaScript intended this to ever be used for. Right? So now let's think about the evolution of this. Right? So JavaScript was cool for a little bit, then it went away, and it came back with a bang in Web 2.0, which many of you might be too young to know about. But it was a really big buzzword in 2004. Right? And this is when the web became a little bit more interactive. You had things like AJAX requests when XML was really cool, DOM manipulation, event-driven programming. Writing JavaScript in those days was a pain because different browsers didn't all support JavaScript, the same sort of JavaScript, so you'd have to write different code snippets sometimes depending on which browser you were on. And then along came jQuery, which was really awesome because you could write the same JavaScript and it worked everywhere. It was like magic. And then people started writing really crazy jQuery. They started storing data in the DOM. I say they, I'm one of them. It was the common practice was to keep data in the DOM, and then it became very difficult to track application state and debug applications. Right? Because if you were reading someone else's code or even your code from a while ago, it became very difficult to get a handle on this. Backbone introduced an MVC model, right? So continued using jQuery, tried to separate concerns relating to where your data is stored, to your business logic, to the presentation. Right? Angular took this a little bit further. But I was an Angular developer for a long time, so I'll be the first to admit it also caused a lot of problems. Right? Because now you can have state in a lot of places. At least with Backbone, state was primarily in the model. And now you've got stuff in the controllers, in the directives, in the services. You've got them all over the place. Some people in the routes and their controllers. So Flux turned all of this on its head. Right? And kudos to React for really pushing this forward. With Flux, you see that we have one-way data flow and an attempt to centralize state management in one portion of the application. Right? And this is where the GraphQL picture fits in with me. Because GraphQL is awesome for a lot of reasons. So, many that you probably know about already. It lets you make very succinct and efficient queries to your backend. You don't have to overfetch, you don't have to underfetch. You can implement it incrementally, so you don't have to completely rip out your REST backend, or if you're unfortunate and you have some other, like a SOAP backend or anything like that, you don't have to completely rip it out and replace it. You can put a GraphQL endpoint in front of everything else, and then you can incrementally roll it out. But one often overlooked aspect is how much it helps you with state management, as well as how you can write a lot fewer lines of code with a well-constructed GraphQL application than you would typically do with a React and Redux application. And Apollo 2.0 kind of takes this even further. So, right, so this is some stuff that I've already kind of gone over. So we want to write JavaScript applications where we're separating concerns, we're centralizing application state, and we're trying to improve performance. Right? Right. So as we started adopting these principles, there was a move more towards kind of functional programming, which supports a lot of these kinds of practices and design patterns. Right? So the kind of characteristic example is where you would use like map, reduce, and filter instead of something like a for loop. Okay? Now, also, we want to prefer declarative programming patterns over imperative programming patterns. So many of you have probably done kind of like SQL before, right? How many of you have like comp sci backgrounds where you've had to do things like traverse a linked list or stuff like that, right? So think about a select query in SQL, right? You write a select query, select, first name from members. You're telling the database what you want to happen. Do you know how it's going to happen? No, and you don't really care. Right? You count on SQL to do this for you efficiently. Right? Compare this to if you had to implement this kind of like in C++ without the use of any fancy tools. You may have a binary tree that you have to traverse. You may have a linked list. A lot of your effort is spent figuring out how you're going to find it, not what you're going to find. Right? So why I'm kind of getting to this is GraphQL allows us to move away from a Redux pattern that many of you have probably seen. And how many of you have done Redux before? It's like a good chunk of you have done Redux before. So in Redux, you often end up with this imperative pattern where you're stating a lot, you're writing a lot of code to specify how you want things to happen, right? So vanilla Redux focuses way too much on the what, right? We're talking about, sorry, they should say way too much on the how and not enough on the what, right? We're focusing on how we're doing things. So imagine a situation now where we're trying to fetch all the members of a blog, right, or a soccer team, or something like that, right? Like the common Redux flow is we have some button or some user action, right? We dispatch an action to say, hey, go fetch this information. Then we make an API call. Then we get a response, and the response isn't in the structure that we probably need for our component. So now we need to normalize that response. Right? We dispatch an action to say we've got the data and it's in the format we want. The store updates itself, and now our view kind of reflects that. Right? So the majority of these steps are focused on how stuff should happen. Right? Whereas we ideally want to focus on what we want to do and not how. Right? Now, this is the big improvement that you get with GraphQL. So above and beyond all the other kind of benefits that you're probably familiar with already, one thing that I'm trying to push myself, and which I hope kind of everyone appreciates, is that we can write a lot more kind of declarative code and get away from imperative programming patterns with the use of GraphQL. Right? And right, so this helps us to read our code more easily, to write our code more easily, to test it and to document it. Right? We end up with fewer bugs, we end up with fewer lines of code, which ends up with faster load times and a whole bunch of other benefits. Right? We can reduce our Redux code also by kind of reducing the number of actions that we need to have. Right? But also you need to wrap a lot of these components in container components that would dispatch these actions. So you eliminate kind of that layer, and you can use higher order components in React as well. I didn't get as far along as I would have liked in a sample app I was putting together. There are 2 blog posts that I really recommend, and one is by Ryan Collins, just implementing GraphQL in your Redux app. So he goes through a really simple kind of Redux GraphQL Apollo app, and he's got a couple of actions here. Is this big enough? Right. So you've got a couple of actions here. So this is generally the pattern you'd follow in like vanilla Redux, right? You'd have your action, then you'd have another action if it succeeded, and another action if it failed. Okay. And then here he's loading the employees. Right? You dispatch the action indicating that it succeeded. If it failed, you dispatch an action indicating that it failed. Right? And here you have the code that kind of does this. Right? So this thing returns a promise. Right? And then it succeeded, catch the error, and then dispatch another action if it fails. Okay? So now in GraphQL, you've got your query. And the GraphQL queries, of course, help you eliminate that need to normalize the object once you've returned it. Because you just write your query in a way that you get the object that you want. Right? Then you wrap it in the higher order component that you need. Right? And the higher order component can get the ID of the employee or whatever. And then as it loads, it fires off the query, maps the result to the props, and then you're done. Right? So you've got the entire kind of application here, just in this file. Okay? Whereas almost the equivalent amount of space was taken up just with the Redux actions. There's no view logic in here at all. There's no reducer logic in here at all. Okay, and the last, and I'm not going to kind of go over this with you because I'll just post the link on that. That's sort of, this is by Apollo 2.0, takes this even further, right, and allows you to kind of write even less code and employ this pattern even more kind of succinctly. So yeah, that's really it for my talk. Yeah, consider GraphQL for your state management as well as for making your REST calls more efficient.
I'm not really here to teach anything. I'm really here to tell a story. It's a really fun story of a startup with way too much time on their engineering team's hands, who is, that engineering team which has iterated over a product way too often, but it at least gives me a good story to tell. So my name is Rohan. That's me. I work at this company called Pungle. We are a fintech company. I'm going to talk a little bit more about Pungle in a little bit, but let's talk about me for a second. I love talking about me. So I'm the head of engineering at Pungle. Really, that just is a glorified title for saying that I'm the lead developer on the project. And sometimes my boss, when he doesn't want to, makes me do some management. Advise a couple different companies, and I've done a whole bunch of other random stuff. The real important part here, though, is not like what companies I've been at. It's more just the different technologies I worked in. I've been in JavaScript for ages, but I mean, those of you who've come to React talks before might have seen me. I've done a lot of different React stuff, but my passion is more on the back end. At the API layer, I like keeping things super, super simple. So GraphQL has always been my go-to, well, at least since my own company, ObjectiveIQ. So that plays like a big role in all of this. It's just that like I've done GraphQL, I've done REST in many different places. GraphQL was just a thing that kind of opened my eyes up to simplicity at an API layer. Let's not bother with going crazy with endpoints, and this is a recurring theme. I don't like writing endpoints. So I want to talk about Pungle. Pungle is a startup I'm currently working at. My old boss started it with his boss at the time. They recruited me in to build the initial product. And basically, I'm going to walk you through the story of how Pungle started, but from a technical aspect, from an architectural standpoint, and also how GraphQL, Node, and Elixir played a part in this big story. At different points in time, I'm going to make up random things I'm going to go on tangents. Really, this is a stream of consciousness thing just to talk about the experiences and how I've really taken all the different opportunities I've had to build and learn and kind of translated them to some rules for success. So Pungle is a payments company. We're a payments company that does quite a bit in payments, but the main thing we're trying to do is real-time payments. We're trying to replace checks, and we're trying to replace really old, antiquated ways of paying people, whether that's a company paying you, whether that's your insurance company sending you a check, whether it's you sending your friend a check, sorry, not a check, but a payment, whether that's you sending your friend a payment, whatever it is, we want to abstract payments into something that is real-time, that is really trying to make it a much better experience all around. So we have a couple different UI products. I'm going to tell the story of why that's the case for a pretty early company. Reporting analytics is a pretty heavy part of what we do. And that's really to go back into finance itself and just being able to clear a transaction. I'm not going to go into finance and clearing a transaction. One of the biggest things we have to deal with is high concurrency, because we deal with enterprise companies that are often sending out thousands, tens of thousands, hundreds of thousands of transactions a month. And when you take a whole bunch of those and put them all together, there's requirements for kind of ridiculous levels of transactions. It's not just a simple notification being sent to one place, it's many different stages. Lastly, we're bootstrapped. So this actually has a really big impact on basically the entire organization and everything that we do. It means that we're really lean. It means that our technical choices can't be, hey, let's just throw a whole bunch of money at AWS and try to scale horizontally. We have to be clever about stuff. So on the right here is like a super sneak preview with the product that we're building right now for a B2C situation. It's not a very good picture on purpose, but it's enough to whet the appetite, I hope. So when I started at Pungle, myself and the two co-founders had a beer in Mississauga at some Moxies, I believe. And they said, yeah, we're going to do some wicked stuff. We're going to do real-time payments. Visa's put out some APIs. MasterCard's put out some APIs. Interact's put out some APIs. Let's connect to that. So I was like, okay, cool. Let's do it in the quickest way possible. And like naturally, that meant I'm going to put up a little node server and just connect to some external APIs. I need to prototype this idea for them. I need to tell them that, hey, guess what? I can finish this off in like 3 days. That's how long it took, because it's integration work. Integration work's kind of easy. So really, here's the starting point of our architecture. Now, this diagram is going to get a little bit crazier, but the starting point was, we're just going to take this stupid Koa server, and we're going to go pass it right through to external services. I named this thing core. Now, it's in green because Node.js is green. The colors do mean something, and I'll explain those as they come up. But really, all we were doing here was just making sure that we could send some transaction through to Visa, and we could show other people, like, hey, guess what? We can actually do this stuff. We know what we're talking about. Super simple. So, let's think about this for a second. Thought about it for a little bit. I'm like, request validation is something that's super important, because when we're sending requests into Visa, Visa needs like 8,000 properties to actually complete a transaction. Now, that's not like 8,000 in a call. It's just like the amount of different things that Visa needs to complete a transaction for me to Leo over there. There's a lot of different steps. So, okay, it's cumbersome to do them in Node. My boss is saying, oh, let's do it in Java. It's like, no, I don't want to do Java. We're trying to prototype right now. Testing, pain in the ass. It's Node, we all know, pain in the ass. There's no ubiquitous testing story in Node. There's no really easy way of doing integration testing in Node. And some people might be sitting here being like, okay, yeah, there totally is. You're completely wrong. Cool, you've got experience there. In our case, it wasn't really what we were focused on in terms of testing doing integration testing of random services. For me, it was more like, let's just get stuff done quickly. That was a choice of Node. Debugging, cumbersome. I find Node debugging cumbersome. Like, I have to pull up VS Code. I'm not a VS Code person. I have to hook it up to Chrome. And like when I started, this was before Chrome had Node debugging in production, like 8 months ago. Coolness factor, like great. I can put up a Node server. I can do some stuff. Concurrency story. It's behind there. It's okay. We all know Node. It's become I mean, this is what makes Node awesome, right? It's not a disagreeable choice. It lets us do lots of interesting stuff, and it's getting predictable. It's not quite Java in terms of the reliability that enterprises look at, or like the managers who are enterprise level look at. It's not quite Rails in terms of getting stuff up to speed really quickly, but hey, it gets the job done. Truly, what we needed. Scaling can go either way. It depends on your experience. Scaling can be, hey, have you really put together stuff that you've done clustering on, or can you scale horizontally, or do you have the money? But if you think back, I said, we're bootstrapped. We don't have that much money. So scaling comes kind of, you need to be clever in that aspect. So I'm sitting there going, maybe, kind of, not really sure if this is the best choice. I need to evaluate. So showed my bosses this stuff. They're like, oh my God, awesome. How'd you put that together in 3 days? Well, I mean, like, I put myself in a situation where I could put it together in 3 days. Of course I got it done. I wrote no tests. I didn't do any testing. I didn't do any request validation. Debugging was sparse at best. But it was like, hey, cool, you can build stuff. It works with credit card networks and external services. Let's build a production platform, which to me is, let's build something that you can do some very interesting stuff with, that can scale, that is not me taking on so much technical debt that I'm gonna curse myself out in a month, less a year. So we came up with some decent requirements, and like by we came up with some decent requirements, I synthesized some of the stuff that we need to do on the business side with some stuff that we need to do for architecture. Enterprise client really meant that we need to worry about proper security, we need to worry about proper data retention, we need to worry about a whole bunch of different things, and one of the biggest parts of it was not dropping any transactions. That comes back later, but not dropping any transactions is a hard thing to do. Keep that in mind. Another one was high throughput. I've already kind of explained why, but really for us as a business to beat some of the incumbent players, we need to have a really sweet platform that could be way faster than anything Visa's ever seen. At this point in time, so spoiler alert, at this point in time, like we're sitting here and we probably have the highest throughput of, or potential throughput of anybody who's actually using Visa's platform. And for us, like Visa was the big player in this market because Visa is the biggest credit card network in North America. And 100% in Canada, especially with Visa debit cards. So we needed like crazy throughput such that we could shock them into white labeling our API keys and allowing us to do stuff that nobody else is allowed to do. We need to do this as a public API as well. I mean, I'm building a platform here. The only way to really do anything is, hey, let's just put this as a public API. Let's sell it to big enterprises who are going to consume this API and then hopefully do millions of transactions a minute. Nobody's actually doing that much, but we can hope. But all these things are important. And I mean, having worked for companies that have done ridiculous amounts of data before was, let's set ourselves up and work towards a proper microservices infrastructure. We have, I mean, being a payments company, we needed to go through a lot of different PCI stuff, which also meant that we needed somebody on staff who was heavily into ops and infrastructure. So we just needed to divide between dev and ops. So, hey, we're gonna have an early stage company that has an ops person. Might as well take advantage of this ops person. Might as well build some good orchestration. We're gonna need a crazy secured down PCI compliant environment. So let's be smart about this and kind of exercise what we can. But like the biggest part of all of this is we gotta hire properly, which means that we need to have an environment that onboarding people isn't tough. We can't have something that's so crazy obscure. We can't be like sitting in Haskell writing stuff because it's not an easy thing to actually find new developers. So we need to find a really good middle point. So here are the options that myself and our CTO basically agreed on to be the final 4 options. So I know it says suck it up, and that's obviously a spoiler alert, but like I think the title of my talk was kind of a spoiler alert in this one. We didn't go with Node. But yeah, we could stay on Node. We could build out from Node. Move to Java. No, we're not going to move to Java. that one was like really early vetoed by me. But like the 2 compelling options, other than staying on Node were Go and Elixir. The concurrency aspects of Go and Elixir, like the stories are very similar because Elixir is a language that compiles down to Erlang bytecode. Go's concurrency story is, it's like part of Erlang's concurrency story. Right, so there's this thing, tiny interlude. Anybody who's trying to really build a proper actor model is going to implement half of the Erlang VM. Because Erlang's VM is 10 years older than the JVM, and the concurrency story there is built to handle all the different phone lines that were up in Sweden and then kind of translated to the rest of the world. More about that in a little bit. But like the two things were like, hey, do we go to Go or do we not go with Go? And like in my head it was, do we go with Go or do we go with Elixir? And my boss said it was, do we go with Go? Because he had drinks with somebody else who said, oh, I want to do everything in Go these days. Really though, I'm the developer on this project, right? I'm the head of engineering. So I said, no, let's veto that. I never really used Go in production. I don't have the experience to pull together Go projects, and for us to hire people to get us to that point where deployment and scaling Go is easy would take a little bit of work. But like the more important part is I like functional programming. That is like the core part of a lot of different things that I'm going to be talking about tonight. I like functional programming. So my functional programming acolytes and friends are out here in the audience. They know exactly why I like functional programming because it's just an awesome way of reasoning how to solve problems. Okay, so now I have two options. And the options here aren't about what is bad about one or the other, as the two options previously have been. I mean, like Java's just like a straight up no. But it was about what are the values that we get when we bring back the initial requirements that we put in. And for me, like Elixir was battle tested, super resilient. In my last company, I actually moved a bunch of services over to Elixir. My main stuff was still in Node, but this was me diving into Elixir and really understanding the power of the concurrency model of Erlang, the power of a properly functional language, not one that is super dynamic in the ways that any Node person, well, the entire Node ecosystem claims it can be, because there's a right way of doing stuff in Elixir. The functional aspect was great. Elixir also got microservices out of the box. And it's in quotes. I'm not really going to go heavily into this, but we get a lot of the interesting stuff that we call microservices or service-oriented architecture. We get that out of the box because Elixir is a language that was built around domain-driven design. Just good architectural principles. And good is a subjective term, and it's something that today means a lot more to me. It means more about thinking about how the right ways of putting something together for specific purposes are, as opposed to ubiquitously good. But yeah, Node didn't want to really do it. Honestly, there were two other really big things. One was our ops guy was going, okay, cool, I don't have to wake up at night. Like literally, this was probably the biggest deciding point. He goes, cool, if it's on Erlang, he knew a lot about the Erlang VM. He'd been in the game for a while. He said, cool, we don't have to worry about waking up at night. PagerDuty's not going to be waking me up when I have to be up at 5 o'clock to when my baby starts crying anyway. And like for me, it was, I mean, I get to come here and talk about how cool I am to do Elixir now. I'm not cool at all. But the main point was I wanted to push the boundaries of what I was doing as a developer, and we had the time. We didn't have to be in production tomorrow. We didn't have to do anything on near-term timeline because there's so many other things on the business side that needed to be done. So we had a lot of time to actually design the system. We had a lot of time to actually scale up. But on top of that, I get a functional language. It's got some really crazy, awesome language features. It's got a runtime that is kind of ridiculous. It's got compile time checks. You know what? We'll talk about that later. The main point here is, though, I moved to Elixir. So Elixir is a language that, as I said before, compiles down to Erlang. Erlang is one of the most ridiculously fault-tolerant systems or languages, and their runtime is extremely fault-tolerant because it's got this thing called OTP, which is basically their networking model built around these concepts called processes. And these processes are completely different than processes you've heard of before. It's more about we need a small unit of work being done. So within this big tree of networked events, something called a supervisor can spin off workers. Now, I'm not going to go too heavily into Erlang or Elixir right now, but I'm going to drop little bits and pieces in to kind of fill in the gaps. So I mentioned before too, we have like a pseudo microservices thing going on. So basically I said, okay, cool, I'm going to put this API layer. The API framework is called Phoenix. Phoenix is a very Rails-like flavor. It's not Rails. And Elixir is actually a Railsy looking a language that is functional like Erlang, but it's not Lispy. So keep all these things in your mind, but it's really not that important. So I had one service, a completely different service, that was hitting my external services. And then I had a different service that was hitting my Postgres. I mean, I'm building a platform now. I need to actually get users and companies and figure out what plans they're dealing with. That little ecto in the brackets there, that's the query building and data connection layer right into Postgres. This comes into play a little bit in the future, but for those of you who are in Rails or have experience with Rails, it's similar to Active Record, but it's not quite as Active Record-y. Magic. But we'll go into that in a bit. I'm setting all these different things up. So, really quick evaluation compared to the node evaluation. Request validation, well, we have the data struct, and struct basically means that I can validate all the different properties that I'm feeding into my data structure, making sure that they actually exist. I can throw exceptions if they don't exist. I can do that at request time, I can do that at response time, I can do that anywhere I want. It means that I just have a little bit more type safety without actually having a strongly typed language. I could do some typing, but I'm not really going to go into that. It's still a dynamically typed language. Testing. First class. It's first class because it's actually part of the language primitives. So when you install a new Elixir app, you get the core libraries that help you actually do the testing. It made it, sorry, and this also being a functional language means that most things are pure functions. So testing becomes quite easy. Debugging is super awesome because I don't need to go spin up Chrome DevTools. Right, I can just put random debugging statements in, and on top of that, the Erlang VM lets me actually SSH right into the shell. So in a running application, I can just go be like, hey, you know what? I want to go see what's happening right now in the memory space. I can go see what's happening with all the different modules that are available and run random code. This morning we were debugging a whole bunch of different things related to SSL, and it was just like, cool, so I'm just going to go into our working application, look at the different logs, look at what's actually happening in the entirety of our microservices application. And it was super easy to actually figure out what's going on. Coolness factor, I think it's high. And you might disagree with me, but there's so many really interesting people who are working on really interesting things on Elixir. But the biggest part of coolness factor is like how many people are actually trashing it on Hacker News, and barely anybody trashes Elixir on Hacker News. So I think like we get a high there over Node. And like this is the most important part. The ease of scaling Elixir and Erlang is ridiculous. There's a ton of different case studies you can read. They're all on Medium because it's where we put case studies of companies going from Java environments to Erlang, or sorry, to Elixir, or Rails to Elixir, and cutting down the number of instances, cutting down the size of their instances of infrastructure, and basically saving a ton of money while getting way crazier throughput. So there's this random story of somebody going from, I think it was like 6 Rails machines to 2 Erlang machines, and then after they did some load testing, it was like, what the hell? This actually went up in round trip time, and it became like a big commotion for a couple hours between a few different developers, all blaming each other, and then they realized that it was measured in nanoseconds, not milliseconds. That's a story that happens a couple of different times. I had a friend tell me that same story. We cut down a lot of different things just because of this previously mentioned process model. So naturally, after I built this, it was, okay, cool, let's do the next thing, right? Business people. Let's build a UI. Cool, that one's easy for me. We're gonna do React, of course, because I'm a React developer. Been doing React for 3.5 years, and I mean, I'm biased. Then they added a little bit more. Right, let's make a white label app. Let's change layouts depending on the configurations, depending on what people paid for. So okay, so I've committed the cardinal sin of I've shown what I can possibly do. I have a second developer now who's actually somebody who worked for me at my last startup. Somebody pulled out of boot camp. He's pretty awesome. He checked this over for accuracy. He wasn't super happy about it. But the main point here was, okay, let's do some crazy layouts and stuff depending on what the configurations are. And so naturally I said server-side rendering. Right, that's the right answer, right? It was just me trying to push myself to a new level in React. So we built an application on top of our existing Elixir application. So all this stuff down here, the 3 Elixir applications and kind of the things that they integrate into, we're going to call that core from now on, because that's actually the name of it. It's one repo, it's a bunch of different stuff, but the one above is, we're just going to call it node application number 1. It's not going to, spoiler alert, it's not going to stay there very long. But the main thing is, I wanted to separate our core application because it also needed to serve as a public API to other people who would be consuming that. I wanted to keep those concerns separate. And on top of that, hey, I get an application that I can use to test just the flexibility of my core application. So we did this wonderful thing where we tried to build a RESTful node, Koa, of course, because I need async await, React and Redux application. Connects into Postgres, but that part's not really that important right now. So I hate writing endpoints. I said that before. I love Redux, but there's so many different things with Redux. Like, I'm worrying about 2 different parts of an application. I'm worrying about a data platform, and I'm worrying about a full stack node React application. The Redux side, it's not really where I want to spend my time, and on our small bootstrap team of 2 and 1 ops person, it's not really the ideal place to spend time. Then it's like, ooh, I need source maps. Debugging, nightmare. Transpiling, complete pain in the ass. Paul and I actually were having a beer the other day, and we had this argument about transpiling node servers. I found her pain in the ass. He doesn't. I needed hot module reloading. And like, really, like the entire team was not very happy with this. Okay. The real thing was, like, it was not an ideal environment. Right? The developer ergonomics of this were kind of screwy at best. So, quick interlude. This diagram up here is one that I made about what REST looks like. And one of the important parts is, of REST is that we have different units of code, and we call them controllers, typically in MVC pattern, and they hit a whole bunch of different data sources. This makes things a little bit interesting, but it also means that I need to write a whole bunch of different endpoints that connect to these controllers, etc. So I'm assuming that everybody, does anybody here not know what REST is? Or should I just not ask because that's kind of shaming somebody? Let's just assume we all know what REST is. If we don't, Google it right now really quickly. Or Stack Overflow. So the thing about REST is, like, things are all over the place. To me, having already used GraphQL at my last company, I said, okay, like, I'm so tired of writing endpoints. Okay, that's actually the main reason, but for me, it was going to GraphQL just meant I can articulate stuff a lot better. I can handle control flow. I can handle business logic a lot better than what we were currently doing. But mostly, it was about developer ergonomics and speed of moving. And so it didn't take very long for me to convince my team, because there's only one other person, and he had to listen to me. We moved over to Apollo client and Apollo server, stuck those in. And so we had a new little architecture. Not very different than the last one, except that we replaced Redux with Apollo. I'm not going to go into the details of why I did that. I did like 3 other talks on that, but the main thing here was we didn't really change a whole lot, except the interface between the UI and that middleware layer. Now, we still have a whole bunch of other things that we can think about. So let's evaluate this. No more get routes. I still kind of have to write my post controllers. We call them mutations now. I truly do love GraphQL. I talk about it all the time. My other problem still existed, but that was more like our fault internally. But we'll come back to that. So, I said before, we had Postgres, but we're also connecting to our core layer. One of the really important things that came from REST is, that came from GraphQL is that I could abstract over what my data sources actually were. My interface layer and my data access layer were completely separated, completely decoupled. I could go and change up recipient, I can go and change up company, transfer, all these different things. I can change up the internals of them as long as I maintain those APIs. This is one of the biggest, awesomest parts of REST. Sorry, of GraphQL, not about REST. It's the opposite. But the main thing though was also, GraphQL gave me something that was pretty consistent, right? I had arguments coming in, I had the root, which is whatever the parent was. I could resolve these different objects in different ways. And I mean, this is actual code that I pulled out. So like, I know this isn't the world's best, but there's so much stuff in here. But my recipient schema is actually hitting my Postgres database, my, what do I call it here, transactions. It's actually hitting my core API. And the thing is, I need to take all this stuff and kind of bind it together and return the same sort of stuff to the UI. And to me, like, the UI experience has to be the lowest touch point that we have within our team. It has to be the lowest touch point because we have to spend so much more time on concurrency, on scaling, on, I mean, all the different crazy ideas that we come up with on how to actually build a platform. And realistically, spending a lot of time on UI work for enterprise products is not a really great way to run a team. Oh, an early startup, not a team, but an early startup, because we just needed to sell stuff and we needed to get money in. We're bootstrapped. But this is one of the most valuable parts of REST to me, to be able to abstract over those data access layers. So naturally, once we got this done, we had to build another UI. That's how things go. But this time we had lessons that we were building on. Right? Like lesson number 1 was like no more server-side rendering. This says Pungle developers, but really it's my other developer, Stash, and he said to me, "Hey Rohan, you try to do that, I'm gonna leave." And I said, "Stash, it's okay, I don't want to do that again. I miss my HMR and I miss my other stuff." But we're building a whole new project. It's a greenfield project. Like I said before, like there's a lot of different things that I got to build in this, and so I got to make a lot of different mistakes. I'm trying to impart that wisdom here. But we also started with GraphQL. And one of the reasons we started GraphQL is because some of the stuff that we'd already built, we could just literally cut and paste over. Not ideal, and savvier viewer thinking like, why would you cut and paste when you could reuse something? Don't worry, I'll come back to that. So, hey, here's more additions to this. I doubled the size of this box to just really encompass the fact that it was doing a couple different concerns, but we added more to this, but it was still coming back to that same core layer. And the core layer was a RESTful API and it was a public API, so I didn't really touch that. But everything else is about the interfaces between the different boundaries. And again, like what I just said was GraphQL let me hit different data sources. And I didn't just have an external services and a Postgres layer, right? I had caching in there. I had a whole bunch of other things. And these external services is not just like one service. There's a whole bunch of different things. We'll get to that in a little bit, but the main thing here was I still needed that advantage that GraphQL gave me in terms of abstracting over that. It decoupled every different part of my application, and it meant that when we were implementing a new feature, we didn't have to go sit there on the entire stack from the top of this little blue box to the bottom of this pink box. We could do this layer by layer, and it made things so much easier for us. Implementation for us was a 50-line change, because it didn't impact every single thing. But it did cascade through the entire application. It meant that, or the entire stack, and it meant that we needed to think more about stuff. But I mean, give me a choice and I would rather think a lot more and design a lot more than sit there and hack shit together and try to later unfuck that situation. That's not what I want to be doing. That's not how we run teams either. I want to be able to build people into these teams and let them adventure and make mistakes and learn how to fix their own mistakes, not fix my mistakes. So we also decided at that point in time to scale core. I already kind of alluded to this, but we split this up into a bunch of different services. This is still a little bit of an abstraction, this diagram, but we have this OTP layer. I've talked about OTP before briefly, but it's the networking primitives that the the Erlang runtime gives us, and Elixir has full access to this. So basically what I was doing was handling all of my other services in a different way. If one died, and really it was like a whole bunch of different workers, if one of the workers died, it didn't really impact everything else. And I also said, like, we're trying to build something for millions of transactions a second, and we're totally over-optimizing, completely, absolutely. If you're in like a time crunch, never do what we did, but we didn't have a time crunch. We had to say, we can take 10,000 transactions and deal with them atomically, and have a whole bunch of different workers that can process them all serially. And if one of those fails for whatever reason, whether that's an infrastructure problem, whether that's an input problem, whether that's an end user problem, whether that's a PEBCAC Rohan problem, it shouldn't destroy every other thing in that set of transactions. And that's what Elixir gave us. That's what OTP gave us. So this is more about why I'm on Elixir for many different things, as opposed to why I'm on GraphQL, but it kind of feeds into everything. These are all the different services also that I needed to hit at different places. And I mean, there's a part of me that said, hey, maybe we should take this Phoenix application and turn it into a GraphQL interface as well. And maybe that's what we do in the future, but it needed to be a public API, and I really don't think that a lot of enterprise developers are going to be sitting there going, hey, let's figure out how to integrate this random GraphQL application. So let's forget about the core aspect, let's talk about the top part. We still had this thing going on. And we kind of needed to evaluate what was happening with it. And I mean, as a team, we kind of sat down, and it's kind of evident when going back over Jira and going back over pull requests and stuff, like we were way more productive in Elixir, just because Elixir kind of gave us better development or better compile time tools and more sanity in specific places than Node did. Because we didn't want to spend our time configuring Webpack or this testing environment, or really, we weren't going to put in TypeScript, we weren't going to put in Flow. We needed different ways of getting up to speed quickly. Error handling Elixir was ridiculously awesome. I'll show a couple lines of code later that kind of go along with this, but the main thing there was handling errors wasn't like, hey, I'm going to have uncaught exceptions all over the place. You know exactly what's going to happen, because it's a pretty binary effect. You can either say that we're going to have an expected outcome, or if that expected outcome doesn't occur, we can just kind of catch a collection of different errors. Similar to a try-catch, but a little bit more powerful. But like, why do we have two API layers for virtually similar apps? Because I made the stupid choice of trying to do server-side rendering. This is where it bit me in the ass. It cut my flexibility because I was trying to be too savvy in different places. So naturally, the easy part there was, let's unify that. Now, part of the unification was us just kind of getting really irritated by some of the runtime bugs that happen in Node. We used to have batch transactions to Postgres that were redundant. And a lot of different small problems that were in NPM libraries. One of the biggest problems for me was Nex. I don't know if anybody's used this, or if you have, it's an abstraction over querying databases, but there's a lot of small bugs in all of that. And these are bugs that I knew existed in this because we come from REST and the same bugs exist in specific places, but on the other side, in my core application, we didn't have all this stuff. Stuff was a lot more predictable. So we unified. We rewrote those two Node applications in a new Elixir application. So Phoenix is the RESTful framework for it, very similar to Node. Absinthe is the name of the GraphQL library. So this is kind of the new architecture of Pungo. We took those two React apps. I removed all of the random crap that I wrote in Webpack, moved it to create React app. There's still Apollo client. That was an awesome part. That was a great choice. One of the few great choices that we made above our core layer. But now we went back to all the lessons that we learned before. So, okay, we have abstractions over different data sources. We get to connect into a core layer. We have create React app. If something screws up over there, we'll just bug Dan Abramov about it. Made life a lot easier for us. And like really what happened is we had proper articulation between the two aspects of our stack. We had our core platform, and it did a bunch of stuff, and it's deployed in a specific way. We have this green thing, it's called Teller, but it's also got like Postgres in it. So if you see Teller from now on, that's what I mean. And we can deploy these things in different ways and scale them in different ways. And this is a really important part as well, because it's not like we're going to stick all this stuff into a particular VM and totally mess up with the memory space of that. We have some specific ways that we can abstract out over time. I can split up any one of these little services on the bottom here into their own specific self-contained services. I can handle those in a different way. I can deploy those in a different way. So much power I get there, and I get runtime level networking. That means that I don't have to worry about Docker containers talking to one another and all that. But the main part here is still that Phoenix layer. It did the exact same things that my node layer did. I had some small parts that were better, some things were different. I'm not quite as good as Elixir as I am in JavaScript, but still got the job done. So let's go look at it a little bit. So I previously said that we separated data access from API. Well, this here is one of the more complicated functionality that we have to create a transfer. So when somebody wants to actually send a transfer, so if I'm sending a transfer to Paul, I need to create that transfer. And well, there's a few different things that need to happen. But like one part of it is that I need to actually create that transfer at the client level. The main part here though is that I could separate my different layers. And this is just a random function that's putting my data into different places. But really, if you look at these functions specifically, repo.insert all, I mean, anybody who's worked with Phoenix and Ecta before will be like, okay, I know exactly what you're doing. But for those of you who don't, what I'm really doing is just saying I have some abstract construct, and I'm doing an insert all method on it. It's a function because there are no objects here. But I'm doing something with it. And the APIs there, I can name them, or Ecto, the library that I'm using, can name them. Doesn't really matter. And if we look really closely down here, we have transfer.create, and that sounds like something you do in a database, but really, that's just hitting my other API. So I have an abstraction over this. What happens behind that abstraction doesn't really matter. But guess what? This itself is an abstraction. This is the only business logic I have in my entire application. This is my GraphQL. Above is my GraphQL schema. Cool, I have this mutation. It's called create transfer. It's taking a single argument of input. That input argument, we're not really going to worry about it, just whatever's going into this. It's an abstraction. And to actually figure out how to return that, well, there's this thing in the bottom. And all it's doing is it's calling transfers.create transfer, which is, hey, this guy. I have all these different ways of separating my concerns, but I mean, that's pretty cool. I get to do my development in different phases, but if you think about it, I said earlier, I can also take all these different applications, split them up into their own different services. I get microservices out of the box without actually having microservices, because I get runtime level networking. So let's talk a little bit about the difference between Node and Phoenix that we saw. So syntax is, like, this is crazy, right? Like, they don't look similar at all. Okay, I guess they kind of do. Control structures are different. Right? There I get to do two asynchronous actions, and I get to look at the return of both of those and do other tasks with, okay, I can do that here too. Right? Like, I'm writing the same code in two different places, just the code is slightly different because it's just syntactical, but the underlying structures are the same. Right? This isn't a very convincing argument to move it from Node to React, sorry, Node to Elixir, but it's not really supposed to be. This is not a talk about me trying to advocate for Elixir here. It's me trying to say, like, we switch for a shit ton of different reasons. But none of those reasons in there is going to be the interface. It's not about GraphQL. The point here of this talk is like really, it's not that. Whatever, pick your runtime. Do it in Elixir, do it in Node, do it in Go, do it in Java, do it in PHP if you're daring. GraphQL allowed us to make all these different moves because it let us maintain our API without too much work. the similarities between the syntax is not because Node and Elixir are very similar, nor JavaScript and Elixir are very similar. Like, there's so much more to it, right? The real outcomes we had here is that we took our 2 random API layers that we stupidly got into, but like, that's stupid in hindsight. At the beginning of it, it was like the right decision. That's why I went through that whole story of all the stupid things I've done. We got rid of Node entirely. And it's not about Node. I love Node. I work with Node by default, but we removed the complexity in our environments. It meant that our deployment strategies were unified. We made it a lot easier to actually get developers on because we're not sitting there saying, hey, you have to go learn React code, and then you have to go learn GraphQL code, and you have to learn Node code, and you have to go learn Elixir code, and they're all going to look different. We have to unify. We have to make our team a lot better and a lot more predictable. We love Elixir, right? Like, it's not my first choice if I needed to go figure out how to do something really quickly on the back end. I'd always choose Node, but if I want to build a high scaling system, if I want to build a new company, I'm going to probably choose Elixir now because of the different things that I like about it. And the people I can hire, they'll either like it or they won't be hired. Just in case anybody wants to work with me. But we didn't change our UI at all. Our UI didn't get touched for a couple weeks. Actually, it wasn't a couple weeks. It was like a week to actually change everything over from 2 different UIs to this because we maintained our APIs in a really awesome manner. But moving between languages always kind of changes up endpoints and stuff and changes up how you're doing different parts of inserting into database and stuff. But in this case, we abstracted away from all of that. We had our different layers, and we got lucky because we chose Elixir, but I'm pretty sure we could do the same thing in any other language. We also learned a whole bunch. And this was, I mean, some of these things are pretty obvious, but the spec is what's important about GraphQL. That's why it was really, really awesome for us. The spec allowed us to go from different languages and evaluate different languages at apples to apples. It wasn't about all the different various flavors of REST. We don't have Rails REST and then Java MVC REST over here. And I mean, those of you who've worked in those 2 different environments know that those are not really comparable things anymore. But we had consistency because the spec, it's not so mature that people have started diverging from it. Everybody's trying to build the same thing that Facebook had said according to the specs that they put out with their initial Node implementation. Migrating stuff was copy and paste. Like, let's go back here. I mean, the transactions behind the scenes are pretty similar, but I mean, I didn't really go into what my schema looked like, but they didn't need to change at all. My transactions schema still has the same properties underneath it, and if I wanted to add new properties, it was going to affect my UI because it's not a new endpoint. I'd have to change much more on the UI than maybe later adding in another property. Again, the super awesome values. But like the big thing here is stack choices are team specific. It's the only real lesson I want to impart here. But GraphQL allowed us to be really, really flexible at what we were doing. Also, I don't like SSR, so I'm really bad at it. So thank you. This is kind of part 1. This is not like part 1 being I want to focus more on kind of how we moved over, but what GraphQL gave us. I'm doing a second one on November 23rd, Elixir TO. If you're interested in like the more Elixir aspects of this, please come out to that event. It's way more Elixir-y, but it's the other side of it. But like really, thank you everybody.